So let us next start exercises 5.3. So we are going to solve a few quadratic equations, and the first one is x square plus 3 equal to 0. So let's see the solution. So what we do in the solution, we straight away write the formula for the two solutions, which we already know. And that I am saying, in spite of having such a simple equation, where actually you can do something else also. Namely, you can subtract 3 from both sides. That way you will get x square equal to minus 3, and then you can take square root on both sides. So that way also you can approach. But it is very rare to have such a simple equation. Mostly you will encounter an equation where you won't really be able to apply this method. Okay, in this case you can do that, but in general you won't be able to. So it's better to just forget about those techniques and straight away apply the ready-made formula that is there for us. And what is that formula? If the original quadratic equation is ax square plus bx plus c equal to 0, then the formula for the roots is minus b plus or minus square root of b square minus 4ac divided by 2a. So that we apply straight away. So in this case, a is 1, b is 0 because there is no x term, and c is 3. So b is 0, that means minus b plus or minus square root of b square minus 4 times 1 times c. c is 3 divided by 2 times 1 because a is 1. So that way you can see that if you take this 4 outside the square root, it becomes 2. And square root of 3 of course will remain, and square root of minus 1, don't forget there is a minus sign within the square root, so that will become I, your imaginary unit. And then after cancelling these 2's, you get plus or minus root 3i. So these are the two solutions. Next we have 2. So number 2 is 2x square plus x plus 1 equal to 0. So in this case, a is 2, b is 1 and c is 1, and accordingly the roots are given of course again by that formula. So minus b is 1, so here you have 1 plus or minus square root of b square, that is 1 square, minus 4 times a, that is 2 times c, that is 1, divided by 2a, a is 2. So that way what are you getting here? Minus 1 plus or minus square root of 1 minus 8. So 1 minus 8 will be minus 7, and you separate 7 and minus 1. So you have square root over 7 and you have square root over minus 1. So that will be I. So that way these are the two roots of this equation. One of them is minus 1 plus root 7i divided by 4, and the other one is minus 1 minus root 7i divided by 4. Next let's see 3. So this is the third one, x square plus 3x plus 9 equal to 0. And of course again we have these two roots. In this case b is 3, a is 1 and c is 9. So minus b plus or minus root b square minus 4 times a, which is 1, times c, which is 9, divided by 2a, 2 times 1. So this becomes, the thing inside the radical sign becomes 9 minus 4 times 9. Now instead of doing this multiplication and then doing the subtraction, I have decided to take this 9 outside. So then it will become 3 and our thing will be simplified. So that way we get 1 minus 4 under the radical sign, that will be minus 3. So that will ultimately become, you have minus 3, so over the 3 you have square root, which is here, and over minus 1 also you have square root, which becomes I. So that way these are the two roots of our equation. Minus 3 plus root 3 times 3 or 3 times root 3i whole divided by 2, and minus 3 root 3i divided by 2. Let us next see 4. The fourth one is minus x square plus x minus 2 equal to 0. There will be a temptation to multiply both sides by minus 1, thereby changing the equation to x square minus x plus 2 equal to 0, which will be equivalent to this one. However, I don't think that will give you any significant advantage unless you make mistakes with minuses. When there are many minuses, if you can't handle that, then you can do that. Otherwise, we just straight away use the coefficients as they are appearing in the equation. That means now for us a is minus 1, b is 1 and c is minus 2, and accordingly the two roots are these. So b is 1, that means minus b plus or minus square root of b square, minus 4 times a is minus 1, so we have put a minus 1 here, times c is minus 2. And make sure to properly use brackets, okay, otherwise you will get very confused. Divided by 2 times a is minus 1. So this part of course is simply 1 square is 1. When you have many minuses and they are multiplied, you see how many minuses you have. If the number is odd, then ultimately you have minus. Otherwise, if the number is even, you have plus. Here there are 1, 2, 3 minuses, which is odd. 3 is an odd number, so you put a minus here. And 4 times 2 of course is 8, and divided by minus 2. Don't write 2 here, okay. You may practice with many such equations where you don't normally see a negative number in the denominator, but it may happen like we have here, okay. So minus 2 stays minus 2, don't change that. And then this of course becomes minus 7, which ultimately becomes square root of 7 times I. So these are the two roots, minus 1 plus or minus square root of 7 times I whole divided by minus 2. You can see that these equations of course deliberately have been chosen so that the roots are non-real complex numbers. Let us see another one, the fifth one. So the fifth one is this. The equation is x square plus 3x plus 5 equal to 0. So in this case a is 1, b is 3 and c is 5. And these are the roots, minus b plus or minus root b square minus 4 times a times c divided by 2 times a. So this becomes 9 minus 20, which is minus 11. So that is under the radical sign, and that will become square root of 11 times I. So these are the two roots of this equation, minus 3 plus or minus root 11 times I whole divided by 2. There are other exercises after this where also you have to solve quadratic equations with non-real complex roots. That however we will do next week in this video on complex numbers. So see you next week with this. Until then, this is me, Lucifer, from a mathematical room. Have a nice day.